Hi and Assalamualaikum. So this is our presentation about radio frequency interference from Physics 260. Hope you guys enjoy. Before we go through to this topic, I would like to share with you guys about group members. From the left, we have the gorgeous one is FARAH NISRINA binti KHAIRUL AZAM. The blue one is HAMNAH binti YAZID FIRDAUS. Next we have HALISA FARHANA binti JEFFRY. The later one is NADIA AMIRAH binti AZIZAN, and the whitest one is NABILA binti JAMRI, and the last one is HAZIRAH binti SHAHRIR. Are you ready guys to know about this topic? Let's get started!
What is radio frequency interference? Radio frequency interference is the conduction or radiation of radio frequency energy that causes an electronic or electrical device to produce noise that typically interferes with the function of adjacent device. It also refers to the disruption of the normal functionality of a satellite due to the interference of radio astronomy. Radio frequency interference can disrupt and disturb the normal functioning of electronic and electrical devices, and thus it is important to limit it when possible.
So the next slide I want to share with you guys is investigate the source of radio frequency interference. So first we have wireless and cellular telephones. We have radios, we have satellites, radar, microwave ovens, and the last one we have televisions. That's the most common sources. We also have a common sources of interference, such as electronic devices. It's identified like common household or industrial devices that might cause interference, such as microwave or wireless routers. Okay, second, we have natural sources. It's considered an environmental factors like flattening or solar activity.
So now I am going to talk about the effects of radio interferences. First, we have interfering radio reception. RF interference generated by mobile phones, portable electronics, consumer appliances, and other devices is capable of interfering with the radio receivers employed for communication and navigation purpose. Next, we have dysfunctioning electronic system. RF interference can disturb the normal operation of electronic systems. And then we have intermodulation and demodulation. When radio interference happens, especially with many different signals at once, it can cause problems in electronic devices. These devices can mix the different signals together, creating new ones that can mess things up. This makes the devices pick up unwanted sounds or signals instead of the ones it's supposed to use. Here are some other effects of radio interferences. We have data corruption. In digital circuits, RF noises can cause timing jitters and subsequently data corruption. Next, we have damage of devices. In high-intensity RF noises in the vicinity of sensitive devices can produce sufficient energy that can cause permanent damage to system components and ultimately the entire system. Lastly, we have medical devices. Many medical devices such as pacemakers and hearing aids are sensitive to radio interference. This can cause equipment to malfunction, which can pose serious health risk to patients.
Next, I would like to share to you about mitigation techniques for radio frequency interference. The development of techniques for mitigating radio frequency interference present in the analog output of radio telescope receivers has been rapidly developing field in recent years. Some of the techniques is proactive measures. This is to change the local radio frequency interference environment by means of regulatory or coordination measures. In addition, some modification to receiving systems may be possible in some situations to exclude radio frequency interference from observational data by using filters or robust receiver design. The second one is waveform subtraction, in the sense of subtracting radio frequency interference from the telescope output. This is form of adaptive noise cancellation is potentially superior to temporal excitation in the sense that the radio frequency interference is removed with no impact astronomy. Lastly is anti-coincidence. This broadly meaning the discrimination of radio frequency interference by exploiting the fact that widely separated antennas perceive identical astronomical signals by differing radio frequency interference. Thus, radio frequency interference makes a contribution to the background noise at each antenna rather than to the correlated signals.
Radio frequency interference in communication system. RFI in communication system happens when unwanted electromagnetic signals disrupt the transmission or reception of desired signals. There are some sources of it, such as electronic devices, atmospheric conditions, and intentional jamming. So, how to mitigate the RFI in communication system? We can use techniques like shielding, frequency filtering, and signal processing.
So next, we will discuss about the radio astronomy observation. So first of all, what is radio astronomy? Radio astronomy is a major branch of astronomy that reveals otherwise hidden characteristics of everything in the universe. And this is actually a significant field within astronomy that involves studying celestial objects such as stars or nebula using radio wave. And how does this work? Radio frequency play a crucial role in the field of radio astronomy. Radio astronomers study celestial objects by detecting radio wave emitted by this object. By detecting and analyzing radio wave from astronomical objects, researchers can gain valuable information about galaxies, stars, planets, and other celestial objects. However, a challenge in radio astronomy is radio frequency interference. The radio signals coming from space are incredibly weak than the signal we use for communication on Earth. To mitigate RFI, radio telescopes are often placed in remote locations away from human source of radio signal, ensuring clear observation of celestial objects. Next is the technique and equipment that we use in radio astronomy observation. First is radio telescope. Radio telescope is used to study the radio frequency portion of electromagnetic spectrum emitted by astronomical objects, and this radio telescope can be used in the daytime as well as the nighttime. Radio telescope require very large antenna to gather enough radio energy to study the planet and other galaxy objects. And these radio telescopes are preferable to be placed or located far away from the major center of operation to avoid electromagnetic interference from radio, television, radar, motor vehicle, and other man-made electronic devices for an easier observation. Second is the radio interferometry. Radio interferometry basically using more than one radio telescope antenna that works together as a single telescope to provide higher resolution of astronomical objects like stars or nebula. And it uses an aperture synthesis technique to combine the separate signal to create high resolution image. And this will produce image with angular resolution of a huge telescope with an aperture equal to the separation, and it calls as a baseline between the component telescope. And mainly this radio interferometry mainly used for the resolution of more luminous astronomical objects such as close binary stars.
In conclusion, radio frequency interference poses significant challenges to various electronic devices and communication systems. To mitigate its impact, implementing effective shielding, filtering, and frequency management technique is essential. Additionally, ongoing research and development efforts are crucial to advancing FII detection and suppression technology for improved signal quality and reliability in our increasingly wireless world.
Here is our reference for this assignment, and thank you for watching.